Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering a question from Module 5, Inquiry question number 4. This is going to be on equilibrium and acid reactions. So, let's have a look. This question is worth 4 marks. It asks us to describe the changes that occur in both the intermolecular bonding and entropy of or when potassium chloride is dissolved in water. We need to support our answers with a labeled diagram. So let's have a look here. First, we know that potassium chloride is a ionic structure. So K chloride K plus looks like this. This is an ionic lattice. And then we know water is a polar molecule. And it looks something along the lines of this. Hydrogen partially positive, oxygen partially negative. Okay? What will happen is the partially negative chloride will be attracted to the the negative chloride will be attracted to the partially positive hydrogen. The partially negative oxygen will be attracted to the potassium. So we get attraction. So that's what we're kind of seeing here, the attraction between these molecules here. So what we know is there will be a breakage. So bonds break. So ionic bonds break. And then we get a formation of ionic dipole bonds. Okay, so that's what we get over here, and that's breaking apart from there. So what can we say here? So we've drawn our diagram. We need to comment on the intermolecular bonding and then the entropy when the potassium chloride is dissolved in water. So change back to the color. So what we know is, in terms of the molecular bonding or intermolecular bonding, we know that we'll get a formation of ionic dipole bonds. We will get a breakage of ionic bonds between the molecules or between the ionic compounds. So we're breaking ionic bonds. And we're also breaking hydrogen bonds between the water molecule. You could probably draw that out as well. So we can draw the oxygen and the hydrogens. So we can say a bond breaks. Okay, and the end product we should be getting is the positive ion will therefore be surrounded by multiple water molecules, something like that. So that's kind of the end product that we get at the end. Okay, in terms of the entropy, what's happening here? Okay, and what we'll also find in terms of the entropy is the lattice itself is very ordered, right? Entropy is about breaking, or entropy is about the randomness or the orderedness of the orientation of the lattice. We can see that by breaking the ionic lattice, this is going to cause the orderedness to disappear. And if they're just going to exist as random constituents of molecules in solution, effectively they've lost their orderedness. So in terms of the entropy, increased as ionic lattice is broken, and also we get a randomized formation of the ion dipole molecules. I'm going to also just quickly redraw this part and just also what the formation of the chloride would look like, so just bear with me here. Okay, so after a little bit of a drawing session, I'll just re-summarize what we have here. So originally we had an ionic lattice. When it's dissolved or when it's placed in water, we will cause the ionic lattice ionic bonds to break apart and the hydrogen bonds between the water molecules to break apart. So that's where we begin to lose our orderedness. From this bit, this breakage, we will see a increase in the overall entropy. We will see an overall increase in the overall entropy as well. As we form as the molecules form together, we're going to form ion dipole bonds between the negative oxygen, negative partial negative oxygen with the positive potassium, and the partial positive hydrogen will bond with the negative chlorine atom. Okay, whilst that formation will reduce a little bit of the randomness, and there will be a slight decrease in entropy from that formation, okay, the overall entropy, the overall net change, will still be positive because the ionic lattice is orientational wise a lot more ordered. One last thing I'll add is when this does break it into its ionic components, they are going to disperse into all parts of the solution. So disperses in all parts of solution, and that is also another reason why we'll see an increase in entropy. Alright, thank you for listening up till now. If you enjoyed this little explanation, give it a like, and I'll see you next time.